Hey everybody, my name is Brandon, and today we're going to be doing a crash course on Private Pilot Lesson 1, Aerodynamics. Okay, first, just a little background about myself. I worked as a certified flight instructor for 3 years before being hired by a US regional airline. I'm making this crash course video series to touch lightly on most of the subjects that would normally be discussed on the ground in pursuit of a private pilot certificate in the United States. Some of the things I talk about might be outdated, so I encourage you to verify the information with the most current Federal Aviation Administration publications on their website here. I also want to point out that these videos aren't intended to be a full substitute for flight instruction, but just another tool to bring awareness about certain subjects. Any questions? No? Great. The 4 forces of flight are lift, weight, thrust, and drag. Weight's the easiest to understand. It always goes to the center of the Earth. Weight can also be referred to as a forward component or rearward component, depending if the airplane is climbing or descending. Lift, on the other hand, always acts perpendicular to the relative wind, which we'll get to in a second. And there are 2 main principles of lift, Newton's third law and Bernoulli's principle. You should have these both memorized. In level flight, lift directly opposes weight, but in a turn, lift acts at an angle. Because of this, we can divide lift into a horizontal component and a vertical component. Centrifugal force also comes into play during a turn. If the airplane is in equilibrium, which means all forces are equal, then the force of the horizontal component of lift matches centrifugal force, while the vertical component of lift matches weight. The combined components of lift are called total lift, while the combined force of centrifugal force and weight is called load factor. Load factor is measured in G's, where 1 G is 1 time the force of gravity. Initially, to start the turn, horizontal component temporarily overcomes centrifugal force and inertia. The same thing happens when starting a climb or descent. Before we talk about angle of attack, we have to define the components of an airfoil. An airfoil is really just a cross-section of the wing. There are 6 main components: mean camber line, leading edge, chord line, trailing edge, camber of the upper surface, and camber of the lower surface. Camber is just a fancy word for curve. Angle of attack is defined as the angle between the chord line and the relative wind. It's important to note that the relative wind is defined as the vector of airflow parallel to the airplane's flight path in the opposite direction. That means it can also come from any direction in relationship to the airfoil. Another way we can change the angle of attack is by using flaps, which can assist with takeoff and landing because they change the position of the trailing edge, which in turn moves the chord line of the wing. There are a few different types of flap designs, as well as leading edge lift devices like slats that are basically all meant to have the same purpose of increasing lift and decreasing the indicated stall speed of the aircraft, which leads me to my next subject, stalls. When non-pilot muggles talk about a stall, they usually think of the engine quitting altogether, but an aerodynamic stall is actually when the smooth airflow over the airplane's wing is disrupted, resulting in a loss of lift. In a stall, the wings still generate lift, but they don't produce enough to overcome weight. This will always happen at the same angle of attack, the critical angle of attack. It's also important to note that there are different types of stalls. If you're practicing a stall and you recover incorrectly, you could enter a secondary stall, or worse, a spin. A spin occurs when the aircraft is both A, stalled, and B, uncoordinated, meaning the tail isn't following the nose in a straight line. In a spin, one wing is stalled more than the other. In other words, one wing is producing more lift than the other wing. Here's a great video of a student inadvertently getting in one. Notice how his controls are pointed in the opposite direction of the roll, causing the angle of attack on one side of the airplane to be greater than the other, which disproportionately decreases lift on one side.
8 miles westbound.
A very common procedure taught to recover from a spin is the PAIR acronym: power idle, ailerons neutral, rudder full opposite, and elevator down briskly to break the stalled condition. Flight instructors are required to complete spin recovery training before getting their certificate. Thrust is developed by rotating a propeller, which is really just a twisted airfoil if you take a closer look. A low pressure area is created in front of the aircraft, while a high pressure area is created behind. Think of a propeller as pulling and pushing the airplane through the air simultaneously. Because the propeller has mass, there are a few left-turning tendencies that occur due to its movement. Torque reaction, which is really just Newton's third law, spiraling slipstream, which occurs because the spiraling airflow strikes the vertical stabilizer, P factor, which comes from a naturally higher angle of attack on the descending blade, or the right side, and gyroscopic precession. Drag is the force that opposes the aircraft's movement through the air. There are two types of drag, parasite and induced. Induced drag is caused by inefficiency of the wing design, and it is a byproduct of lift. That means the more lift that's developed, the more drag the wing creates as a result. Parasite drag, on the other hand, is further divided into skin friction, form, and interference drag. Adverse yaw is an effect that happens because of an increased amount of drag on the wing that is raised in a turn. As this happens, the raised wing develops more lift. With more lift comes more drag, and bing bong, you have a roll to one direction with a yaw in the other direction. That's called adverse yaw. This can also happen in a turn as the turn is progressing because the outside wing is moving faster. More airflow equals more lift, which equals more drag, so this may cause a slip if you fail to use rudder in a turn to remain coordinated. Manufacturers have tried to come up with clever ways to eliminate adverse yaw from the aircraft by using freeze type or differential type ailerons. By the way, a slip is when the tail of the airplane is on the inside of the turn. A skid is when it's on the outside of the turn. In both scenarios, the airplane is uncoordinated. Ground effect is a phenomenon that decreases induced drag when flying near the ground because of reduced intensity of wingtip vortices. Sometimes wingtip vortices can be dangerous to small aircraft, and we call this wake turbulence. Tower might say, caution wake turbulence, which is your cue to stay above and beyond the larger aircraft's takeoff and departure path, or, if you're landing, to stay above and beyond the larger aircraft's approach and touchdown point. Wake turbulence can also be affected by light crosswinds, which can possibly keep a vortex over the runway. Stability is defined as the inherent quality of an aircraft to correct for conditions that may disturb its equilibrium and return to continue on the original flight path. There are two types of stability, static and dynamic. Static stability is the initial tendency for an aircraft to return to its original position. Dynamic stability is an aircraft's overall tendency to come back to its original position over time. Manufacturers can make design changes to increase the stability of the aircraft. For example, increasing dihedral is one of the ways they do that. An aircraft can have different stability characteristics about each of its three axes. This can be a little confusing because longitudinal stability is stability about the lateral axis, while lateral stability is stability about the longitudinal axis. This is a VG diagram. It shows the limitations of an aircraft as a function of airspeed. Notice that once the aircraft exceeds maneuvering speed, it has the capability to cause structural damage to itself. Maneuvering speed is the maximum speed an airplane will stall prior to causing structural damage to itself at high load factors, and it can change depending on weight. If an aircraft is heavier, it needs a higher angle of attack to maintain lift, which causes a stall to happen sooner should the aircraft experience severe turbulence. This ultimately allows for a higher maneuvering speed. And that pretty much just about covers it for basic aerodynamics. If you'd like to see more of this content, consider subscribing. If there's a topic you feel needs more attention, feel free to leave a comment below. I hope you learned something, and until next time, see ya!